Just record this presentation and okay. Good morning. Good morning, everyone, and thank you. Thank you for being here today, and welcome to a Building Real-Time Data Pipelines, a Practical Guide. So today we are going to discuss the ways to basically use data streaming technologies to be able to implement a real-time data pipeline. So I'm pretty sure that you have noticed in some of your projects that you worked on, you probably encountered some issues where the data perhaps is a batch process and you're lagging behind on presenting the real-time information or the data in a more uh, in a better frequency of time as opposed to just waiting for a batch to complete every 4 hours or 5 hours or so. With the real-time data integration, you are able to do that up to the second or minute, depending on the requirements of your projects. So, but anyways, to get started, there's a lot of materials. We have a lot of materials to cover here. There's a GitHub project. So you can just scan that you see on the screen if you want. That's going to take you to a hub where you will see links that can take you to the different projects, GitHub, and some of my resources that I have created and shared with the rest of you. But now let's talk about real-time data pipelines. And welcome to anyone else that's joining today. Welcome and thank you. So my name is Oscar Garcia. I'm a software engineer, like a lot of you guys. I do work on enterprise applications using cloud technologies related to web, data, AI technologies. I love working on enterprise solutions and sharing some of the stuff I learned over the times, every time I worked on a different project. I'm also an author. I wrote the book about data engineering process fundamentals. And this book is about the data engineering process. It takes you through a journey where we start with a concept and do some discovery process, and we take you through all the different phases to implement the data pipeline. Real-time data pipeline is part of that process. And we'll be covering some of that stuff today. And there's a lot more information on the GitHub repo and also on the book. All right. Just a little recap and overview of the concepts that we're visiting today. So we are talking about data engineering process fundamentals, and where it is beyond just the implementation effort, but it covers a lot of areas, right? Discovery, design and planning, the data pipeline and orchestration, data warehouse, data modeling, data analysis and visualization. Today, we're covering data streaming. And what you see there is a link to the GitHub project. If you didn't scan the QR code, that can take you there. If you like the project, please give it a star. That keeps us going, keeps us adding more information to the project. But let's get going. So what is data streaming? What is this thing that we are talking about today, right? It really enables us, going back to what I started saying, it takes you back to a real-time integration, right? When you start doing a batch process, usually we schedule that batch process to work every hour, every 2 hours. It really depends on the frequency of the information. With a real-time data integration, usually the information is available right away, right? So it is what's called a continuous data flow, right? It actually enables us to integrate with systems that are sending certain events, right? And then we catch those events, and the events get processed into the data pipeline. The diagram that you see here, basically, it kind of contrasts the. This is the entire enterprise solution here that you see. It actually compares what's a real-time integration versus a batch process. And if you look at the GitHub repo, it covers all of these areas here. It implements every single one of these boxes that you see in front of you. So the idea here is to compare that we do have a batch process, and now we are integrating into a real-time data process, but how we leverage some of the existing code that's doing some of the data processing. And that's what we're going to talk about today. We're going to talk about covering implementing a real-time data integration and leveraging some of the data transformation processes that we have already in place so the data can flow the same way. And there are no data collisions or problems in the system that's already implemented. So the end product of this will be more frequent data that's represented on data visualizations using Tableau or Power BI. In our case, we're using Looker, which is kind of a Power BI tool. The benefits of data streaming really is that the data comes in instantly. It's the frequency that it comes is in real time. And that enables us basically to be able to predict trends with more in a more timely fashion, right? As opposed to waiting 5 hours for something that happens, we can be up to the minute with this information and make better decisions. And it enables us to update the dashboards, right, up to the minute, to the second, depending on the integration. One thing here to sort of understand when we're talking about data. Real-time data integration, and when regards to the dashboards, for the dashboards to really represent the data in real time, they need to support a WebSocket integration, right? And I have another presentation of that to one of the GitHub repos that gives you a more of a web front end with WebSockets doing a real-time integration as data is pushed into the data stream connection. So what we're going to build today is the area that you see below. We're going to tap into a real-time integration. We're going to create a message broker using Kafka, and we're going to do the data processing using Spark. So first of all, let's understand a little bit more about the streaming, right? So how is it that the data gets delivered to us, right? How can we tap into this information? So usually the data stream channels are basically HTTP endpoints, TCP endpoints. If you go more in the back in the day type integrations, right? But the specific channel really depends on the type of integration that we're doing. So, but at its core, really what we're trying to do here is we're trying to catch an event, right? So some of these systems, right, throw an event, whether it's an IoT device or maybe a Redis cache system or something that actually triggers an event, and it will actually push information to us. So this is commonly referred to the pub and sub model, which is a publisher and subscription model where publishers can publish information and a subscriber basically gets this information. That's very common with IoT devices, right, and other systems. Webhooks, which is really mostly for another push-based event, which is really where you actually publish an endpoint and you tell the system, look, I want to get some of your events. You can just push this event to my system using this endpoint. And API, which is more of a pull model, right? So the push versus pull model we're waiting. In a push model, our system is waiting for the data to arrive. In a pull model, we have to go ahead and implement our own solution. We have to go ahead and say, let's go get this data and let's go pull that data. And because of that, then we got to do something like some kind of a scheduling, right? To say we got to go pull data every so often, right? So in that model, we just got to play with the frequency of time and how often we're going to do, but it still becomes a real-time integration as far as the data processing layer is concerned, right? So even though it's an API and you have to be pulling data, but the way the data arrives into the data processing layer is really in real time. As the data is available, it is there, which is really the understanding of how to consume the data streams, right? So at its core, right, what are the systems that we can leverage to do that, right? So at its core really is to create a data pipeline, we can use Apache Kafka, which is it's a distributed streaming platform, right? It's very powerful, very powerful. It really its main job is to be able to consume data from different devices. You may not hear about Kafka in many implementations. You may hear things like Event Hub or Confluent and things like that, but they really just they're just really branded Kafka implementations that are done by maybe Microsoft or Google. They all have their own implementation, but at the engine, the core engine is the Kafka streaming platform. And next to that, then we have what's called Apache Spark, which is really now Spark is more powerful when it comes to data processing. It's heavily used for transforming, for data transformation, data processing at large scale. The way Spark works with Kafka is that Spark has a streaming capabilities. So what that means really is that it taps into a Kafka topic, and we'll cover a little bit more of that. And it is able to listen, to subscribe to events as they're coming in through Kafka, and is able to get that data and process that data. And we're going to talk about some of the requirements of what that means for us to, what do we need to do to model the data to the requirements of our data pipeline. But it's important to understand that Spark is going to help us in doing that and processing that data to the way that we need it in our system. Right. Let's move on. So what are the components? So once you start, you understand the system, the core systems are really Kafka and Spark then, but how do we do this, right? What is really the implementation? What components that we really need to build and put together so we're able to make this work? So really what we start with is we definitely need a source, right? We need a real-time data feed that comes from some system. And then we need to start creating a message broker. To create a message broker, we leverage Kafka, and Kafka supports many languages, right? We can use Python, we can use C#, we can use Java, and so it supports a lot of programming languages. So today we're going to be talking about Python, right? So, but we create a message broker, and really the message broker, what it's going to do is we're going to implement a data consumer and at the same time a data producer. So it is a data consumer because it actually connects into this data source and it gets the data in real time. But it's going to turn around and understand what the data is for and create and send the message in a topic, right? So at that point, it becomes a producer, right? So it pushes the data to the different channels called topics. And these topics, think about it like a queue, right? It's kind of a queue where we're adding messages in there, and then a consumer, like in this case, we're going to be using Spark, becomes a consumer, and then it just listens to that topic. So it's really saying, hey, I want to listen to topic A, topic B, and as I get another message into that queue, basically, I'm going to process that message and do some work with it. And in this case, as we process that data from the topics, we need to sort of understand what the requirements are. What is it that we need to do with that data? In this use case that we have, we're talking about I'll give you a little bit of background of that process in a couple of slides, but I just want to tell you that the whole idea behind it is that as the Kafka consumer gets all this data, there's going to be massive amounts of data. We don't want to serialize this data like per every message, right? The key here is that Spark is capable of creating messages, files, and drop them, or it's able to connect directly to a data source, let's say a data warehouse, and it's able to put that data there. In our case, what we're really trying to do here is we're trying to, if you go back to this data flow or this chart, we're trying to tap into our data lake, right? So Spark is going to tap into that data lake because we already have a data transformation pipeline that's going to pick up data from this data lake, process it, and put it into the data warehouse. And the end goal to do that is that we don't duplicate code. We don't want different codes doing different data processing because that's going to give you a collision problem, data duplication, and things like that. We already have a good model to do what's called incremental data updates into our data warehouse, so we want to leverage that. So the idea, therefore, is to facilitate that process by creating aggregated data files. That means really is as the data comes in, the data is doesn't have totals. It only has, like, for example, so many visitors come in, and the consumer is going to process that data in a window, right? It could be an hour, it could be 5 minutes, it could be 30 minutes, it could be an hour. It really depends, but it's going to create aggregation. So think of it like in the terms of SQL, a group by. So it's going to create a group by a category or a field that provides a category that we need to group by, and we'll see that in more in the background information. And we then write to blob storage or to the data lake, and then that facilitates the process. But enough of that background. We sort of understand a little bit about how Kafka and Spark works. Let's take a look how we can go about to sort of do discovery and understand how that works, and do some level of implementation. So when you go and load that GitHub repo, just quickly, what you want to do is load this repo here. I want to blow up the screen a little bit, right? And what we have is we have a series of folders here. So it takes you through the entire process, right? This from discovery to infrastructure with Terraform, data pipelines, data warehouse, data analysis, and data streaming. That's what we're talking about today, right? So the data streaming folder, you have a lot of the resources you're going to see today, but understand this is only data stream, and there are a lot of other components here to it. But the end goal, if you want to read what is it we're trying to achieve here, you can just read the whole thing right here, and it will give you a problem statement. What is it we're trying to achieve, which is create some kind of geofence type technology, and what is the approach, and what is the end result, what kind of data visualizations we need to build, and so on. So it gives you all of this. Okay, so eventually we're going to look at Looker at this dashboard that is actually connected to our data warehouse, and we'll see how this entire process that we're going through right now is going to tap into these data sources, right? So if we go back to today, so we're going to add more recent data, so it's able to tap into that more recent data and show you some of this information. Okay, so but that is really what this whole data flow or data pipeline connects throughout. Okay, so please give this project a start. We need more stars here to be able to keep it alive. So let's go back to let's see this live, right? So all right, so what you want to do here is once you open that GitHub repo, you want to go to that folder, right? So let me blow this up a little bit. I hope it's not too, I hope you can see there. But you want to go to folder where we do the data streaming step, which is step 6. And what you want to do is open this Jupyter Notebook, right? So I use Jupyter Notebook for a lot of data analysis, the proof of concepts, prototyping, and so on, right? It gives you that ability to play with the data, with the information, and be able to do this work. Now, what you want to do really here is just experiment. How does this work? How do we interact with the system, right? And if you go to the GitHub repo, then I'll give you, I provide the information on how to install Spark, how to install Kafka, or tap into a cloud system, right? Like, for example, Azure Hubs or Confluent or whatever systems. But if you want to do your own local installation, you can go and download the container files, the Docker container images for these systems, and then that way you can create your own sandbox to be able to do that. But here we're running this, right? And we're loading the definitions, we're loading our Python libraries, we're loading something called PySpark that enables us to interact with Spark, right? So the first thing we're gonna do is we're gonna read the configuration files, right? And the configuration files, what that is really is a way to set up the security keys and so on that we need to, right? And this is going to be running on a Linux box basically, and it's going to read that configuration file and create that, because we're going to need that for be able to connect to it, right? So let me load that really quick, and we're going to be loading a Docker Kafka property, right? And what this is really saying this is how we can connect to a Kafka cluster, basically. So these are big systems, right? These are like database systems that are running in the back, and they're basically providing a cluster for us to connect to so we can process the data. And if I have, I'll give you guys some, I'll show some of the Confluent Kafka systems that in the cloud that is free to use with small resources, right? With little resources, so it becomes free for you. But essentially here, as we define our configuration path and we load the settings for it, we can now create a Spark session. And Spark session really is a connection, right? So this basically creates an application at this point. So this is starting a Spark application that's going to be able to listen to our data stream, and it's going to be able to start processing some of the files. Right. So the point now is that now we know that there's going to be a data stream that's going to be running. So we're going to start that data stream, and all of these steps that I'm doing right now, they're documented on the GitHub repo. As you read it, you'll see how it makes sense what I'm talking about right now. But it's hard to cover everything in 45 minutes. So that's why you have the GitHub repo to follow through and things that you missed. But we're going to start this producer, and what this is, I'm going to take a look at that pretty quick. It's really going to launch a broker, right? A user that's actually going to be able to get messages and produce messages for us. So this one is listening, and it's already getting records, and you see some of these records already being shown here. They don't make sense a lot right now, but we'll get more into detail of that. But it's just there is a producer listening here. So now we know that producer is using a topic called MTA turnstile, right? That is the topic that we want to look at. So, and what that is the queue, right? That's the queue where messages are being sent. We pass all the configurations, the login, the server, all that stuff which is required. And this based on your cloud provider, right? There's some of them have different requirements, but most of them have the same 85% compatibility on the settings, right? And what we're gonna do here is we're gonna do some kind of stream handlers here. What that means is really these functions here are gonna cache data frame streams, right? And they'll be able to write to a stream channel to do what we need. So for example, we can write it to the console, or we can write it to a file. And we're going to write it to a file into a data lake, right? So we have the write to storage function, and that's going to handle writing it to storage. All right. And what we want to take a look at this now is the schema definition, right? So we understand Jews, but what do they look like, right? So this tells us what the schema should be for us to read this message and understand what the data looks like. And where does this come from? That comes from the back we're going to cover after this. But just understand right now we're kind of prototyping. We're saying, hey, we need to read this. And when I load this other function called parse messages, which is really its sole purpose is to grab this raw data coming in from the queue, from the topic, and process it, parse it out, do some kind of configuration like remove, clean, or maybe rename some columns. So this is part of that data processing that Spark is really good at, right? So, and we're using Python, PySpark to do this kind of work, right? And this one here, what this one does, it really does the window aggregation. So what you will see here as we read it, it's actually saying, okay, as I process this data stream, I want to now aggregate it based on a set of fields, right? And that means we want to aggregate it based on the station number, the unit, the division, and the date. And this actually creates another stream, but it's aggregated now, right? So we have one that's transactional and another one that's aggregated. And that's the one we're interested in because that's what we want to get from our data pipeline, from our data lake, right? So what we want to do right now is we just want to go ahead and read through this, and we're going to start a Spark consumer stream, right? And we're going to load and deserialize the message. So we have a serial value of the serializer here. What that means is really the message comes in serialized in a format, right? So as the producer serializes that message, we need to deserialize that message as well, right? So that's what this is going to do. right? So this is actually now creating the stream now, and it's saying, hey, we're going to process this stream. Okay, I forgot to load aggregated process batch. Okay, I forgot this one, so I need a process batch. Now I need to do this. Okay, Kafka options not defined. Okay, so the one thing here with you need to be careful on running all the cells, or you can run the whole cells at once, but I usually just do, where am I, configuration? Okay, here, Kafka options. Okay, now it's there, and now we should be fine. So you run these cells, and that is like function declarations, right? Otherwise, you can't find it. We parse the messages. I'm trying to make sure that all this is, we aggregate it, and so on. So now we're gonna, I don't need this. We're not gonna add it by a station. We're just gonna process the batch, and we're just gonna go ahead and run it. So now this should be good. So now it's gonna do is gonna say, okay, I gotta set up, I got a Spark stream that's gonna come in. I'm gonna get messages. I'm gonna display what the schema for those messages looks like, right? So it's saying this is what I for the message structure looks like. So it's giving us all this information, right? So this tells us more or less how do we need to deserialize the information. And then here we're gonna actually load, we're gonna read that data. So we're gonna say, hey, I want to use the schema and I want to parse these messages. I want to stream that data to the console, and then I'm going to aggregate the data and also stream that to the console, right? So this is really listening. If you see at the bottom, right, you see something flickering on the console, you see how messages are coming in. This is really what this is doing now, is actually saying, I got two schema definitions. I got one for transactions. I got one for aggregations, right? And it's actually now reading and processing the messages as it understands the messages, right? So as they come in, it's going to start creating what's called batch. And as you can see that now, it's processing, it's in a different stage, processing a different batch. And it's going to display how what the data looks like, right? So it's actually saying, hey, this is what I receive, right? And the aggregations, remember, they run every 5 minutes. They'll keep appending data and that for that particular window and aggregate the data. And once it is ready, it's going to go ahead and write it to the data lake. In our case here, if you notice, we commented out right into storage. We don't want to do that now because we're really prototyping. We really just want to play with it and understand how this works and how this data is coming in. So right now here, even though it's just not really clearly, you don't see, this is Jupyter Notebook, so you don't clearly see how the data is being processed and all that. But you understand now that you are listening to a data stream. You're outputting some of the details here, and you can see the output is being processed. Now we got another batch came in, right? So we can see it's processing batch. It's already out there, and it's just waiting for the output, the window for the aggregations to come in, right? So, and that's why these two schemas are different, right? The batch 2 aggregated window is not ready. It hasn't gone through the 5 minutes. So, but this is how this works, right? And this is going to continue to process and process and so on and so on. And you can have Spark and Kafka. They have admin windows that you can actually open, and you can see the batches, you can see the data flow, you can see all that information that is processing, right? Through console, through web UIs that are available for that. But we won't take a look at that because we'll run out of time. But at this point, what we want to do is we know our prototyping is working. We know our coding is okay. We're listening to it, to a Kafka stream. So we're going to just go ahead and stop this. We're going to stop this this process. So we're going to just go ahead and say, hey, stop any connections. I just don't want to process any more information. And that's how you clean sessions for Kafka. Right. So this is the way, hey, find any active queries and stop them and just stop Spark altogether. We don't want to process anything. And for just going to break through that, Control C, and just break through that process of the producer and just say stop producing. We're not going to catch anything anymore. So we're going to stop that. We're going to clear this, and we're going to go back to, now we have a prototype. We know how this sort of works. We coded around it, and we sort of understand how this is going to go, right? So we're going to go back here, and And now that how the implementation works, and we have some background on how the installation is done after you look at the GitHub project, then let's talk about the real use case. How do we use this? What is the whole purpose of this? So the background here, this entire project is all about the New York subway system. As people travel to the subway system, they go through these gates. And if you're not familiar with New York, it's a big city, right? So you have millions and millions of people that are going through these gates. So these gates are equipped with sensors to track everybody that's coming in, right? And everybody that's leaving. So you can catch, I'm sorry, you can catch both of them, right? So the whole purpose is to capture this data, track where people are coming in and leaving in the subway system, so we can have a geolocation, identify kind of a geolocation, and be able to solve some of these requirements that we need, right? The way that this data is presented most of the time is via batch. So it's a batch process. We pick up the batch file, and you can look at that on the GitHub repo. How do we pick up the file? How do we process the file, and how that batch data pipeline looks like? But we want to convert that into a real-time data pipeline. So the data specifications is sort of what we saw, right? We played with that data, we looked at some examples, and then we have to create the schema and the model to define what those are, right? So we know that that we have these different columns and the names and the data types, and eventually what we want to do is create an incremental model that's going to go into the data warehouse. What does that mean, right? So what that means is we want to keep adding deltas in data warehouse. As we process the data, we want to keep pushing new information into the data pipeline. That's essentially what we're trying to achieve here, right? So what we have done already, we have noticed that we sort of do a group by these categorical fields, and we kind of sort of prototype that, right? And we did that. And then we need to aggregate based on entries and exits, which tracks who is coming into the subway and who is leaving the subway station. And as a result, we sort of noticed the sample result of our Jupyter Notebook output. And this is really what we're trying to achieve here. So what is the solution architecture for that? So we sort of play a little bit with Jupyter Notebook and did some programming, but how we're going to really build this, right, in a real production environment. So it's important to understand that here is that we need core components like Kafka and Spark. So obviously, if you read the background of the repo, you see how you can deploy this using Docker images, right? And that's really the same approach we want to do once we start deploying this into our environments, right? So we need to identify the real-time data source, right? We need to implement our message broker layer, which is going to have the broker instance, which with a Kafka data consumer and a Kafka data producer. The data producer is what's going to write to the different topics, data topics, or queues, if you want to call them that. And basically, on the other side of that queue, there's going to be the stream processing layer, which is going to be which is implemented by using a Spark instance, as we saw. We create with Python, we create Spark instance. Yes, and we are recording. It will be. I'll send an email with the recording presentation after. And welcome to everyone. And then we're gonna implement a Kafka consumer that's actually gonna consume the data and Spark application to process the data, aggregate the data, part and so on, right? And we're gonna then write to the storage, and we're gonna write basically, and it's kind of hard, right? If you go back to the background of the entire project, we're gonna write a compressed file with this aggregated information, so our data transformation pipeline picks it up and processes the data. Right. And all of this, part of the solution architecture here is how we're going to deploy, right? And the way we're going to deploy this, we're going to use Docker containers, right? So we're going to write our code, we're going to create Docker containers, and we're going to put the information into those containers, build the images, push those images to Docker Hub. And as we deploy to a new instance, a new VM, then we download the Docker images, and that's how we do manage our deployments. And all of this is done through cloud providers like Azure and GCP, Google. AWS. They have their own engines to do all of this work, but this is really the way we do it hands-on, right? This is a hands-on implementation. All right, and so as we write that data into our data pipeline, then we go into what's called the incremental strategy. And eventually what that means, essentially what that means is that we pick up that file, we from the data warehouse, it processes the information, it picks up the station information, and it pushes new stations if there are new stations. Usually you won't have new stations because that's not built every day, in the booth, and then the fact table with the actual measures, right, with how many exits and how many entries and so on. And that's the kind of stuff we're trying to look for. So part of the data lineage is to showcase that, to show that, hey, we're processing this data that we write into a data lake, and it's going to eventually flow into our fact tables. And there's a whole presentation on data data transformation and data warehouse, and you can look in the YouTube channel, and it's also part of that GitHub repo. And I'll be scheduling more presentations about that. Okay, so what's the impact here in the data visualization? That as soon as the data comes in into our data warehouse, then our dashboards will be enabled with that information, right? So it will be to read that data, right? So this enables us to refresh our dashboards with a much faster speed, right? But remember what I said though, for the real-time updates. So for example, if you want the dashboard to be live and to be flickering and upgrading numbers and all that, your dashboard needs to implement a WebSocket connection, right? So you need to actually have a WebSocket connection that's streaming data into the dashboard, not just putting the data into the data warehouse, right? So you get the data into a data warehouse, but that's not enough. Now, if you don't want to hit refresh, for example, right? The refresh button, you need to actually now, the next step will be that as the data is pushed into data warehouse, another trigger will send it through a sort of a socket connection via many ways, right? It could be a Redis cache, a broadcasting data, or some other implementation where you can actually pick up the data and send it, and the dashboard is capable of understanding that. All right, so we see that now, and we go back now, and we sort of understand that how this works. So so the whole goal of writing all of this is to now write the code to do the same thing with book. You can quickly go, once you go to the project, you will see that you have a Spark folder and a Kafka folder, right? And the Kafka folder is for the Kafka implementation layer, and Spark is for Spark, right? So what you want to do is, if you want to look at the Kafka implementation, you look at the program within the Python folder, right? The program file, and that takes you through the process of doing the implementation, right? It's the same for the Spark, right? So we look at the Spark folder, and I hope you can see this if it's not too small. And you can look for the program file as well, which is open here on the consumer end, right? And then you will see the client Spark implementation, which is essentially what we did is we sort of implemented our Jupyter notebook into a better code, right? We implemented this better functions and a class, and we're able to, but you notice this really what we wrote on the Jupyter notebook, right? It's doing exactly the same thing, right? So it's really saying, hey, let me go ahead and parse out some of the parameters, arguments that I get. Let me go ahead and call this flow, data flow, which has a decorated function. And if you notice, every time you notice here, this is a higher level function. Is really more for be able to track telemetry data on how we process this information. But this is really just doing the same thing. It's saying, hey, let me get the topics, let me get the group, let me get the client, and so on, right? So the settings, right? And this is really going to do a Spark session, and it's going to do the same thing with it in the Jupyter notebook, right? It's going to go ahead and streams, it's going to the data streams, it's going to parse the message, it's going to aggregate the messages, and eventually it's going to write it to storage. And write it to storage really quick, what that means is really going to go ahead and use a component that we have, and it's going to write the information to some data lake that we already have set up on the cloud. Right. Quickly, by reading the information on GitHub, you follow that page, you'll see all the details there. it gives you the instruction, how to run it. For example, it will say how to run this, right? So really quick, going back here, if we go to data streaming, right, it will just take you through the process, right? These are the files, these are the folders. This is how you do all this work that we're talking about, how to install Docker. It gives you all this information, right? And how to review the code and what this means. So don't worry if you feel like I'm going too fast. It's just the subject is pretty extended. So, and it just shows you how to do this, how to run it, how to monitor, and how to how to start the services and how to execute this process. So just kind of get the essence of what we're going through, and then you can go back and with more time read this. So the same thing here. So we start our producer, and our producer is really just going to be sending messages, right? And then we're going to start our consumer. So there's a batch file here, which is really a bash. I meant to say bash file here. That's really just meant to say I want to run my consumer application. I want to run it with a particular connection string, right? And basically what this is just tells it what are the connections. For example, do you want to use Azure? If you can see below, if you want to use Azure connections, you want to use Confluent, you want to use Google. This is really what gives the connection, the keys, the security for it. That's really essentially what those settings. So here, what we want to do is we just want to say bash, and we want to run the start consumer. And the start consumer file, really what that is just really doing exactly what we were doing in our notebook, right? It's really going to go ahead and say, hey, I need to install my dependencies, right? I need to set up my virtual environment, set up my dependencies, and start running this. And you can see now actually loading, connecting to Spark, created the session, and now it's just waiting and starts the streaming app. And now you can see it's loading all the dependencies to talk to Spark. And available, you see the schemas as we saw on the notebook, right? So he's saying, hey, I'm waiting for this batches to come in, and a batch is how Spark processes the data, right? Puts it in batches and starts working on that. So what's going to do now is it's going to start reading the data. It's going to look at snapshots that it has, because it's like a database. It has also like a database system to understand where it is when it comes to the picking up data. So remember, these are very resilient. If they fail, once you restart them, they're going to pick up where they left off, right? So they're going to go ahead and say, hey, where am I? What's my offset? What is my information? Where do I need to do this? And it's going to go ahead and do that. So as this is running, right? So this is going to be running. It's going to be processing data. One thing that you want to take a look at is, before we run out of time, is that you have another you have another Jupyter Notebook file here in the Spark folder. And the purpose of this, really, you can run it, and what it's going to do, if you pick up the Python kernel here, as you run it, it's gonna be able to. We're gonna be able to give it some configuration in this case, and be able to read from our data lake, right? So basically, here just pick, and it's actually, you see it's an aggregated batch, right? It files there and aggregated that information, and we know that because it doesn't have the entire set of the information; it has the aggregated set of information, right? So, and what we're gonna do here is we're just gonna take a look at the files in our data lake. Right. So this is just going out there to Google Cloud and looking at the files in our data lake. And what you can see here is we just created a batch, right? Sort of we aggregated a bunch of messages that came in, and we created a compressed file on the Google Cloud lake. And we can see that because of the date, right? So it's actually 7/24, which is today, at 12:45, which is right on the dot as to complete our presentation. But what that does, it actually gives you the capability of saying, okay, now that we put the data, and now you can query that data. So now we just grab this data, and I know we're almost time, and you can query this data right from the data lake. You can connect to it, and you can say, hey, and this is the data basically that we just picked up, right? So test station 2, because we aggregated based on that test station, and we can see the dates, we can see the entries, everything that we saw at the bottom of the console, we can see here by querying the data lake. And how does this translate now into the data warehouse? If you look at the data modeling, this file taps into the data warehouse, where you can actually now go ahead and query and say, model the data based on what I need and process the data. It takes you through that lineage, picks up the data and processes the data into the data warehouse. You can read that too, but this is really the process to move all this data around. So, all right. So, yes. So the takeaway is that real-time data integration enables us to get the data there quicker. Just learn a little bit about Spark and Kafka to be able to implement kind of the efforts, this sort of projects. But there's a lot of data to unpack on this. I mean, this is usually more than an hour set, but I try to pack this into 45 minutes. But you have a bunch of information. You have the GitHub repo. Please give us a star. You also have this book there. If you got this, goes into more details, more background, and also some of the exercises and explanations on how to do this kind of work. Yes, and the repo is really on the. If you scan the QR code, that will take you to a bunch of links where you can actually go ahead and look at the YouTube channel, look at the GitHub repo. But all you got to do is just Google MTAOZKRY. I'm writing it on the chat, and the link will be, let me see if I can quickly get it for you. It's right here. I'll put it in the chat. Right, and you just want to go through the process, read it, understand the background, understand what we're trying to do, and if you need more information, go ahead and look at the videos, look at also the book. I think we're running a promo on the book right now. I think it's about 50% discounted for a for an ebook. Take a look at Amazon and go to Amazon and look for that book, and you will see that it's actually more than 50% off right now that you can get for an ebook. But anyways, I definitely want to thank you. Thank you all for being here. Thank you for taking the time to visit and allow me to speak to you. But please keep in touch. Reach out for me. Send me any questions you have. Visit the GitHub repo. Please give it a star. And thank you. And keep an eye on the chapter as well, as we create more content, more topics to discuss, like AI, web development, data engineering. Okay. So thank you, everyone. Have a good day.